Hello everybody, today I'm going to explain the first problem of the 2024 December USACO contest from Bronze Division. And this problem was called Roundabout Rounding. And in this problem we are given a process in which we can either round a number to the nearest power of 10, to the nearest 10 to the b, or we are given the possibility of doing, let's say, some sort of a cycle rotation, or let's say rotating digit by digit. So for example, in a way we can either rotate, let's say, around 446 to the nearest 100, and it would be 400. Or if we have 446, we can rotate it to the nearest 10, and it would be 450. And then we would rotate to the nearest 100, and it would be 500. And from there we would stop. And also we are explained here the process for the 456, where by rounding it we can also get the 6, and then we would get the 460, and then basically it would be 500. Again, the process is basically more or less rounding either on one type or of the other type. And in this problem, we are given both the normal rounding as well as the chain rounding I explained earlier. And our goal is to find how many integers between 2 to n exist such that the results of the normal rounding as well as the result of the chain rounding are different. And obviously we are given a lot of test cases, and also a lot of the values of n can be very big. So from the first reading of the statement, it's obvious that in the final solution we can't simulate, because simulating the chain rounding for every number from 1 to 10 to the 9 is not going to be fast enough. We can probably get some good partials by doing it up to 10 to the 6. We would get up to the test case 7. However, in the end, it's not going to be enough. And the fact that we have such big constraints requires us to think at a way to find maybe some pattern regarding the numbers which work. And this was actually the first thing I ended up doing. So basically I simulated the normal rounding as well as the chain rounding for all numbers up to 1000. So I went for some small numbers. And after the first run of the code, as you can see here in this brute force version, I tried to print the numbers for which the answers were different. So basically the numbers for which the answers are different. And after I first ran this brute force code, again, it's a very important thing to do, especially when you don't have an idea right away and the problem is more like one of these math problems like this one, or you will see this technique even in more advanced problems. It's often good to start out with writing some really slow solution, which you are confident that it's correct. And you can use this slow solution in order to be able to gain valuable insights which guide you towards finding an optimized solution. And this is actually what I ended up doing. And when I did this, I realized that the numbers for which it was working were 45, 46, 47, 48, 49, but also again 445, 446, all the way to 499, and so on. And after doing a few more runs, I realized that the ranges for which the numbers work can be actually found using a relatively nice pattern. So you can see that the numbers have only 4s except for the 5, or we can go all the way to the 4 followed by as many 9s as digits we want to check. And given that these patterns are relatively easily to be used from this point on, we can actually check for each value of n the ranges we found in this previous step. And for each range, now the question is whether n is greater than the first value in the range, and if so, whether it's greater than the second value in the range or not. Now, because the values in the input are up to 10 to the 9, you will have to be a bit careful when it comes to multiplying the numbers from the current range to get to the next one, because if you have the numbers with 9 digits and you want to multiply them by 10, if you're using C++ or Java, multiplying these numbers by 10 will have you overflow, and it's ideal to use a long data type, either long from Java or long from C++. Python users don't have this problem. You can multiply them without having to deal with integer overflow. And this is actually what I ended up doing in the optimized solution, where I started with the range for 45 to 49. And while the leftmost value was at most equal to n, I had two cases. Basically, if the entire range can be covered by n, then we just add up how many numbers we have in a range. This is a really standard problem. If you have a range a to b, you will have b minus a plus 1 numbers. So again, we used here some math. And in order to get to the next range, you can observe that I figured out these two formulas, where for the first number you can multiply by 10 and subtract 5. I even wrote here the operations behind it. And for the second number you multiply by 10 and you add 9. And because we only have a single range to check for each number of possible digits, and we have at most 9 digits, this means that the complexity of our code is going to be log of n, or given that this value is at most 9, we can even say that it's O of 1 for each test case, but for a more rigorous explanation, it's actually log n, because we will check each number of digits until the number of digits of n. And after doing this, after I coded the brute force, then I realized that I don't need it anymore. I coded the solution and it passed from the first submission. So the first submission, I got it right, and it can take a few minutes once you find the pattern regarding the groups of numbers which work. Again, for problems like this, I would say that the most important insights are finding the brute force, as well as finding the pattern from the brute force, as well as making sure to avoid any sort of overflow issues when it comes to multiplying the numbers. If you enjoyed watching this video, please like the video and subscribe to the channel. And if you have friends or people you know who are interested in USACO and want to learn more so that they could promote the divisions, you can show them this video, or you can even recommend them my website where they can interact with me in a more exclusive manner. Until the next time, stay safe, have happy holidays, and good luck with the rest of the contests. See you.